Let's try writing out some difference of two squares. So the smallest one that's going to, well, that's not going to give a zero answer is going to be 2 squared minus 1 squared. And that is 4 minus 1, it's going to be 3. So we can do that one. So maybe the next one to try, I could either go 3 squared minus 2 squared, or maybe I'll just try out 3 squared minus 1 squared. So that's going to be 9 minus 1, it's going to be 8. You could, by the way, also write this as 3 plus 1 times 3 minus 1. That's what you do with the difference of two squares. Then you get 4 times 2, which is 8, but it's quick enough for these small numbers to do it just by figuring it out. So it's definitely not going to be C. 4 squared minus 1 squared is going to be too big. It's going to be 15, so I'm not going to write that one down. Right, so next up is 3 squared minus 2 squared. And that's going to be 9 minus 4. It's going to be 5. So, okay, I can get 5. And then maybe we try 4 squared minus 2 squared. That's going to be 16 minus 4, 12. Okay, that's too big. So I'm going to need to go up to the next one. 4 squared minus 3 squared. 16 minus 9, that's 7. Okay, so we're down to the last two. So I reckon it's going to be 5 squared minus 4 squared to look at next. That's going to be 25 minus 16. So that is equal to 9. Okay, so the answer must be 10. Suppose we've done it using trial and error. Not trial and error, but just like trying some out. But how can we show for sure that we can't get 10? I suppose you could argue that we've done it through exhaustion because every one beyond this is going to be greater than 10. If you go 6 squared minus 5 squared, it's going to be too big. You could also maybe look at x squared minus y squared is equal to 10 and then factorize like we did before. And this is going beyond what we need to in this question, but if we did want to, show that we couldn't get 10. Um, and now it must be that either x plus y is equal, right, so there's some different options. Now x plus y, let's assume that x and y are positive. It doesn't actually really matter because if it's negative, then we'll still get the same thing as if it was positive, but let's just assume that to make life easier. Then x plus y is going to be the bigger one. So we could have x plus y is equal to 10, and then x minus y would have to be equal 1, because I'm timesing two things together to get 10, and these are both whole numbers. So I'm looking at the factors of 10. I can actually solve this now using simultaneous equations. Then I would get 2x is equal to 11. That's not going to give a whole number solution, so you can see that it's not possible to do it in this way. The only other option would be that x plus y is equal to 5 and x minus y is equal to 2. That's the only other factor pair of 10. And this time, if you do simultaneous equations, you'd get 2x is equal to 7. Again, a non-integer answer. So that's evidence enough that you can't get 10. Going beyond, like I said, what we need to in this question, I wouldn't start with this method. I'd just try the numbers out, but it's quite nice to see. And you could try this with other numbers, um, and you'd see like if you tried to make it equal to 5, then you would get a possible answer, and you'd end up getting. Actually, let me show you why not. So let's look at the situation where x squared minus y squared is 5. Then it would be x plus y, x minus y is equal to 5. So the only option actually is x plus y is equal to 5 and x minus y is equal to 1. Two things multiplied together to give 5, and these two things are both whole numbers. That's the only possibility. X plus y must be bigger. If I then add them, I'm going to get 2x is equal to 6, and that will give me x equals 3, which is okay. It wasn't okay before because I didn't get a whole number, but it's okay here. And that leads to y equals 2. So that's another approach that you could make for all the other answers. And importantly, in general, if you just had any number, how could you test it? Okay, when it gets larger, it's going to be much more difficult because you're going to have more factors. But in principle, this would work.